try that again. I just realized my microphone wasn't working. All right, try that again. I should put a checklist or something in there. Let's see here. Is anybody even watching? Okay. So sorry about that. Let's try that again. I just realized my... Okay, so the choice, when we have an EVPN VXLAN network, we have a choice. Do we do head-end replication, head-end replication, also known as HER, also known as ingress replication? Or do we do multicast? And they both have their advantages and disadvantages. So, for example, benefits of of head-end replication is that it is a simpler configuration because there is no multicast configuration, at least in the underlay. So just a simpler way to do it. So the type 3 routes builds a flood list of VTEPs that a given L2 VNI needs to flood to. So it's one of the 5 unicast route types. Before we had EVPN and VXLAN, you either had to maintain a manual flood list or use multicast. And the flood list would just be like, here's just a list, a literal list of the VTEPs that we're going to flood these flood frames to. But the type 3 routes build that dynamically. And let's talk about the head-end replication method or mechanism. Type 3 routes build a list of VTEPs for a given L2 VNI to send, or just any VNI, to send a copy of a flood frame. So let's see if we can just build a quick diagram of what that looks like. Let me open up a new, my old, like the type 5 EVPN route. I'll just copy and paste one of these diagrams. Yeah, there we go. Yeah, spines and leaves. And so flood frame comes in from a host. So this will be our host 1. And then I'll use one of the tables that I made here. Flood list. So BVNI 10,010, for example. Leaf 2, leaf 4. So just be a list. So these flood lists so these flood lists would be dynamically generated by whenever a leaf would instantiate a L2 VNI, it would generate a type 2 route automatically, and then that would get propagated through the spines down to the other leaves, and then they would add it to the flood list. So that's how we get that typically. So that's head-end replication. So that's the control plane. How do we get those? How do we get that flood list built? And then when we receive a flood frame, so let's do the numbering method here rather than doing an animation. So step number 1. Oops, didn't mean that one. I meant this one. And I'll do a list of numbers and I'll make the text white. So number 1, host sends a bum frame. So that's unknown that's a broadcast, unknown unicast, multicast. Step number 2, leaf receives flood frame, makes a receive flood frame. Number 3, sorry, number 2 here. Number 3, leaf consults with flood list, creates a copy, creates 1 copy per destination, VTEP. And then number 4, let's say it was for VNI. Yeah, so this will be number 4. I'll make some arrows here to show us sending it. Move that up a bit. Move that up a bit. Oops. Move that up a bit too. So leaf consult with flow list creates 1 copy of the frame per destination, destination. Therefore, forwards each copy to their destination VTEP. Maybe I'll do this. I'll do number 2, and then I'll do a call out to show that this is the VLANs sent to VNI 10,010. Just to or 10,020 in this case. So it goes at leaf 3 and 4. So that's how we do head-end replication, and that's the default in Arista. So what do we do? How do we do multicast replication for an L2 VNI? And let's talk about the mechanism. Let's talk about the benefits of multicast. Scales better with larger numbers of leafs, and then also scales better with lots of bum traffic. Multicast infrastructure handles distribution of flood frames. Because only one copy of flood frame is sent to multicast group, multicast infrastructure handles distribution of copies to leafs that subscribe to multicast groups. So what'll happen is that every VNI will have a multicast group that it's going to flood to. So in this case, or rather, each VNI is configured to subscribe to a multicast group. When a bum frame is received, one copy is sent to the multicast group. And the receivers will take multicast, will take frame and flood it locally. So that's how that works. Leaf forwards a copy of the flood frame to multicast group. Leafs that, or VTEPs that subscribed to the multicast group will receive a copy of frame, of flood frame, and then flood locally. Think globally, flood locally. Receivers. All right, so in our scenario here, let's do a quick scenario. Let's build out the leaf spine topology that I'm going to use, and also the logical topology. So I don't have 3 spines, I just have 2. So when we're going to do PIM sparse mode, PIM sparse mode, and then we're going to do rendezvous points on spines, anycast. And we'll do, I'll configure them as loopback 10. I don't know why I picked loopback 10. I don't know that there's any convention for the rendezvous point loopbacks. I don't think that there is. I could be wrong. Like when we're doing EVP and VXLAN, the convention is to use loopback 0 for your EVPN overlays and then loopback 1 for your VTEPs. It doesn't have to be that, but that's kind of what we typically use. So I'll configure loopback 10. Pick an RP address 255.210 or 201. Now, one thing I was doing was playing around a little bit earlier is I was trying to get AVD to create an underlay using loopbacks for flooding, and I don't think it can. I wasn't able to find anything that looked like it was what you needed in order to configure the flooding and the underlay to be done by multicast. Now, there's ways to do it for the overlay. You can configure how you want to do flooding for multicast and the overlay, but not for the underlay. Because as far as I can tell, this command right here is what actually tells the switch that for VLAN 10 we're going to flood to 239.0.0.9 in our case for a flood group, as far as I can tell at least. And then for PIM, we're using a rendezvous point of this IPv4 address for this multicast group. So that's the multicast group I'm going to use for our flooding. And then it's one multicast group per VLAN, or per L2 VNI, which is one per VLAN. So I think we can do it that way. Some of this was configured via AVD, but AVD is, like I said, as far as I can tell, can't do it. So then I can have a multicast thing here. So I need under configs, I'm going to do spine leaf.txt, and that's just going to be like notes. So for my leaf, so I configured some of this stuff earlier. Some of it was configured by AVD. So these are the things that we need to configure. Spines, pimp. Yeah, so that's what we're going to do. All right, so it's got the AVD configuration on here. I'm going to remove it by deploying where's the deploy original. So this sets the original configs. Oh, no, actually, you know what I want to do is I want to deploy, I don't want the original configs. I want the simplest for the Arista world, which is like their default, which is head-end replication. Deploy head-end replication, eBGP all active. So no MLAG, no unnumbered. So it gives us a good starting point. And let's go to leaf 1 here. Okay. Show BGP EVPN summary. We're established. We're good there. So Ethernet 10 set for access VLAN 10. I don't think show run interface 10. E10 not configured. Good. Go to 3, show run interface E10 or E11 or 12. Okay. Let's go to 4, show run interface E10. Okay, set for VLAN 20. So what we're going to do is we're going to move this to Ethernet configuration. Change this to switch port mode, access VLAN 10, because what we want, access VLAN 10. Show VLAN. We want that the flood frame, we want the MAC learning still to be EVPN. That's the one thing I want to check is like in the days before EVPN, you had two choices to do MAC learning. One was floodless, or you could use multicast. We had to mimic the flooding of unknown unicast. And that's how we did MAC learning. That's how we populated the forwarding tables of the remote leafs. Is we would send them a unknown unicast, and that would put it into the local VLAN table. Here, we want to make sure that EVPN still does that job. We want MAC learning to still be via EVPN, but we want the flooding to be handled by multicast and not head-end replication. Because if you have a very large network, let's say I have a network with 100 leafs, and they all have VLAN 10 on them. If I do a flood frame on leaf 1, I've got to make 99 copies of that flood frame and then serialize each one of them out my uplinks. So that could cause some additional latency or just generate a lot of traffic. So if I did multicast, I would send one copy to the spines, and the spines would disseminate them down to the leafs. So it's still a lot of broadcast traffic or a lot of flood frames, but it's a little bit better if we do it on the spine than if we do it on the leaves. Now, or if we just had a lot of multicast traffic or a lot of, not multicast, a lot of bum traffic in general. So we're not talking about doing anything special with actual multicast traffic in the underlay, or the overlay rather. There's ways to handle that more intelligently, but here we're just talking, what do you do with the flood frames? So we need to create a multicast configuration on the leaves and the spines. So if I just copy this and I go to all of the leaves, so go to config mode. Config mode. And we're just enabling PIM on the interfaces. Also, I need to do this. Now, I should be doing this in some sort of automation, and I'll get to that in just a second, but I want to get the config working first before I do the automation part. All right, now go to the spines. And then on the spines, it's config mode Ethernet E3 through 3, 4, 5, 6. And that's PIM IPv4 sparse mode. Now to verify this, I'll do show IP PIM neighbors. And I can see I've built neighbor relationships with the other leaves. I'll check the other spine just to make sure. Show IP PIM neighbor. Okay. Now on the spines, we've got to configure the rendezvous points. And on the leaves, we've got to configure the rendezvous points as well. So interface loopback 10. I'm going to do, so I need to configure it on the, I don't know if, I'm still uncertain on how to do this. Here's the problem. The Arista documentation doesn't tell you how to do this, at least not the parts that I have access to. So it's not in their EVPN docs, it's not in their VXLAN docs. And as far as I know, Arista AVD can't do it either. So I'm kind of going blind here. I haven't seen any blog posts about it either. So the easy button isn't there. So I'm going to write the easy button. So interface loopback will be IP address 192.168.109, or let's do 10.1 to 199.10. And do I need to do IP PIM sparse mode on the loopback? No, I don't think so, at least. And then router PIM sparse mode, IPv4 RP address 10.1.199.10 for 239.0.0.0/22. And then Anycast RP is 10.1.99.10, but locally it's going to be 10.1.255.101 and 102. And I think I can just copy and paste that to the other spine. Another thing is I'm not exactly sure what the show PIM or IP PIM rendezvous point. Okay, that looks, I think that's okay. Like, I think I'm doing this right, but
you sure about that? 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 You sure about that?
yeah, so I like to use, I've got a couple of soundboards here just to make, lighten the mood, like Inception.
Dogs and cats living together, mass hysteria.
Actually, it's going to be super easy, barely an inconvenience.
And then the newest one is...
You sure about that? You sure about that? You sure about that?
Yeah, so, yeah, I'm not sure about that, actually. Thank you for asking. All right, so next up, show run interface VXLAN 1. So by default, it goes to head-end replication. I think if we do configuration mode interface VXLAN 1, if I do VXLAN VLAN 10, flood group 239.0.0.10, and then I'll do 20. So if I do show IPM route, that looks like we've joined those multicast groups, I think.
You sure about that? You sure about that? You sure about that?
Think so. I think we're good. In terms of that, I've got M routes to those rendezvous points. So yeah, so show run interface VXLAN 1. So I'm just going to copy this, go to the other leafs, paste it into there. And then I do show IPM route. Got a lot. Look at that. Everyone's subscribed, I think. I think this is right. Okay. Now, let's see if the flooding works. I'm going to go to host 2, show IP interface brief. All right, interface config mode interface E122 channel group. No channel group. And then no interface port channel 1. That's from previous config. So just cleaning that up there. So which one did I configure that on? Leaf 3, show run interface E10. It was leaf 4, show run interface E10. Yeah, it was on leaf 4. So on host 2, config mode interface E2, just plugged into leaf 4 on Ethernet 10. Go to config mode interface E2, no switch port, IP address 10.1.10.12, and then Leaf 1. Interface E1 through 12. No channel group. No interface port channel 1. No switch port. IP address 10.1, 10.11. So let's see if I can ping 10.1, 10.12. Oh, son of a! I'm on Leaf 1, not Host 1. I did this yesterday too. Sometimes your brain gets all mixed up. Sometimes my brain gets all mixed up. No IP address. Switch port. Okay, so I think I fixed that. Host 1, not Leaf 1. Interface, show run interface E1 through 2. Yep, so I got to interface E1, 2, no channel group. IP address, interface E1, IP address 10.1, 10.11. Oh, no interface for channel 1. Ping my default gateway, and I can ping the other host. So, if I do show ARP, so that's the MAC address of host 2. So I do, the MAC learning somehow worked. Now let's see if let's see if we can see if it worked via, EVPN or if it worked by a flooding. I'm not exactly sure how to do that. Show VXLAN VNI address table. Okay, so we learned that remote MAC address apparently by EVPN, and I can find it on 254.4, which is Leaf 4, which is where we have it. We did still generate IMET routes, but I don't know if we're using it. I don't know how to confirm if the flooding is actually using the multicast groups. Let's see if the contextual help. Interface VXLAN 1. VXLAN, or VXLAN, was it VLAN? 10. Nope. VXLAN, VLAN 10. Flood behavior. Member. What's the difference between member? Multicast source address. Yeah, I don't think that's what we're looking for. VXLAN VLAN 10 flood group. Yeah, contextual doesn't really help. So I do know that if I do show IPM route, we seem to have joined those multicast groups. I guess another way I could do is I could try, what's a good way to generate a lot of flood frames? I could try pinging. How am I gonna test this? Broadcast, own unicast, and multicast. I could try generating a lot of multicast traffic. I could try a lot of flood traffic. I could count multicast packets. Let's try that. Because there's a counter, show interfaces counters. There's a multicast. So what I'll do on leaf 4 is interface E3 or E4. I want to shut it down. So now I have one path. I think. Yeah, one path. Or I should have one path. Show IPM route. So it looks like I've got one path. I think that's one path. Show IPM route. Shows Ethernet 3 and 4, and here just Ethernet 3. Okay, so it looks like I've got one route there. So that way I don't have to worry about the eCMP. And I'll do show interface counters incoming. Okay, so multicast packets. All right, so I got one with multicast packets. Let me go into host 1, and I'm going to ping 192.1 or ping 10.1.10.2.29. That should have generated one. 20. That should have caused a flood packet. Didn't come in. Well, the unicast packets aren't really going up that much either. No, they are going up a little bit, but not a ton. What if I... What if I did Container Lab? Some of the labs have Linux. Do a Linux node, and then on a Linux node I can do like iPerf for broadcast. What about a broadcast traffic generator? Can iPerf generate broadcast packets? Yeah, so the ping wouldn't generate a broadcast probably in the, because we got ARP suppression going on. So I should turn off ARP suppression, and then I could see the broadcast. Okay. So what if I pinged? Can that work? Ping the broadcast address. Sniper broadcast in Linux. DHCP? Ooh. Maybe that'll do it. What if I did IP address DHCP? All right, so I think I'll probably have to try multicast, because the unknown unicast would get caught by learning, so it wouldn't get broadcast. Let me go to spine 2, just shut down all the ports. Interface E3 through 6. Shut down, because we want only one path for this. So just one path. Show interface, counters, interface. Ethernet 3 counters. No broadcast packets going out. That's interesting. It's because I'm plugged in leaf 3. Okay, so that. No, I don't have it in the table because I did not. Ping 10.1.10.1. Ooh, forget the MAC address. Yeah, it's on leaf 4. Show interface. Ethernet 3 counters. So we have, oh no, we have a multicast packets. We have no multicast packets sent. We have some in. Well, that's broadcast packets, multicast packets. Yeah, we know out multicast packets. So what if host 2, interface E2, IP address DHCP? Because that'll be broadcast. Didn't send anything. Interesting. So yeah, that one hasn't sent any multicast packets either. All right, I'm going to have to reconfigure with, unless I could do multicast. How am I going to do this? Let's reframe the problem. The problem is I'm not sure if broadcast and multicast is using multicast in the underlay. It appears to be working, but I don't know if it's still using head-end replication. I don't know a command that'll verify whether or not. So show VXLAN VNI 10010. I don't know how to verify whether it's using head-end replication or not. I don't even know if it can do multicast as the underlay. I assume it can, but I haven't been able to actually find any documentation that says it can or can't. So, showsbot. It's the swear word from Mork and Mindy. I don't know why I just thought of that now. I'm going to grab some more tea and probably I'll come up with a solution. All right. So what do we... another thing is, do I need to do the L3 VNI? Good question. I don't know. VXLAN 1. So VXLAN VRF blue. Multicast group. Underlay multicast group address for encapsulation. No, we don't want overlay. We want underlay. Is that overlay stuff? No VXLAN, VLAN 10, multicast, group. Learn restrict. Multicast group. Flood group. VXLAN VRF blue flood. There's no flood group, just multicast group 239009. Did we join it? No, it didn't join it. Yeah, we wouldn't need we wouldn't need any flood behavior there, so that should be fine in the L3 VNI. All right, so I'm going to have to generate some sort of multicast traffic. Okay. So what I got to do is I got to create a new topology entirely. Well, I got to modify my existing topology. So I need to replace my hosts with just some generic Linux images. So I can run iPerf. I think I can run iPerf on the hosts themselves, but it gets a little wonky because of the namespaces, because it's Container Lab, or it's a Docker. Let's see if I can figure out how to... Let's see if I can just run it on the hosts. So I go to bash and sudo bash, some super user, and it would be yum install iPerf. Oh, there's no repos. Ah, crap. You know what? It's just gonna be easier to. Oh wait, is there iPerf already on there? Yeah, there is. All right, iPerf. Dash server. So iPerf multicast. There's a way to do multicast with iPerf. Server, UDP, broadcast. Let me try this. And I'm going to use 224 because that's the one that should always be flooded no matter what. All right, so join a multicast group apparently. And then go to host 2. And bash, sudo bash. Then what was it? This may not work just because of the way. Huh. Holy crap, it worked. I think. Neighbor. Show interface counters. No errors. Show interfaces, Ethernet, 3 counters. It says no multicast packets out. And this one didn't see anything come in. I should have seen it, so it didn't propagate. The other thing is, I don't know if Container Lab supports, or not Container Lab, CEOS supports multicast. supports forwarding multicast. All right, so we got here's the, I got a couple of unknowns. I don't know how to actually configure it. There is no configuration guides I've found online for configuring EVPN VXLAN in the Arista world with multicast as the as the flood mechanism. So that's one problem. Number two, I think I've configured it, but I don't know how to verify it. There's not a command I can find that'll say you were doing head-end replication or you were doing multicast. Number three, I don't know if containerized EOS even supports forwarding multicast in the underlay. I know it supports multicast, but if I send if I put a packet into an L2 domain and it's broadcast or multicast, will it actually get distributed through the EVPN fabric? Will it in-cap? That I don't know either. So I've got these three unknowns. All right, so I don't know. So the only way I know, okay, I'm going to have to build a container lab container with a Linux host. So there's kinds. I need a Linux, just a Linux container. So I'm going to let's use Alma Linux as a just because I'm familiar with it. Docker. Forget how to add these. Where's the Docker container repo Alma? Docker hub. I don't want to do it this way. How do I frickin' do this? Container lab, Alma, Linux. I could load it to my local repo, I guess. Yeah, I guess I'll just do that. But where do we get it from? Where's the link? I don't want the Docker file. I want the container image. See, this is one of my frustrations with documentation like this, because they're just like, oh yeah, just install the Linux Docker, but there's no installation, or I can't find out where to install the Linux, like the image management. Oh, maybe this was Docker.io. Let's do Docker.io. Well, maybe it's on Docker.io. No. Product. No. All right, let's just try this. So one of the problems is when I'm running iPerf in Docker on a containerized EOS, I think there's some namespace issues. I'm not in the right namespace, and I don't want to mess with that. So let's replace this with Linux. Then it's Docker IO Alma. What was it? Alma Linux. Alma Linux 9.6. I think. I gotta reconfigure everything, but that's all right. So destroy all those and then recreate it using the new Docker file or container file. Deploy. DMD. Yeah, sure, why not? We'll just download this one. Copy link address, and then wget sudo yum install wget. All right, so sudo docker load -i Alma Linux, and we'll call that Alma 9.6. Image load. Yeah, there's two ways to load an image in Docker, and I always forget which ways it is. Docker load I. Okay, so load I. Docker load I. So Docker image load Alma. For frickin' sake. Valid header. I actually fixed some documentation on this. It was Juniper. Was it CRPD? Yeah. The Docker load I should be in here, but for Arista, it wants it a different way. Import, Docker import. Yeah, there's two ways, and it's really confusing. Import or load. So sudo docker import Alma Linux. Invalid header. Maybe this is not a Docker image. What the heck did I just download? Container images. Docker Alma Linux image. It's on Docker Hub. Docker pull Alma Linux. Okay, try that. Oh, that was easy. All right, Alma Linux latest. I think it might be 10. All right, let's try that. Sudo container lab deploy. Oh, yeah, I need to put both. So the reason why I'm deploying the Linux images as hosts instead of containerized EOS is because there's namespace issues with trying to run iPerf, and I don't want to mess with those. More tea ASMR. I'm gonna go make some more tea. I'll be right back. All right, so to get to the Docker containers now. So they are, I don't know if they have an IP address. Can I, probably can't ping the SSH to them just yet. So if I SSH admin at host 1. Yeah, well, it's good that it's got that in there. So we can do sudo docker exec it host 1 bash. There we go. I'm on host 1. dnf-y install IP tools. I think IP tools. Where's IP tools at? IP route 2. Nope. Yeah, IP route. Okay. All right, so there's my, yeah, so I think, okay, this is the, all right, and then I'll do iPerf. Perfect, okay. What about OpenSSH? System control, start. OpenSSH. Host, do we want to? I don't care. Let's do host 2. DNF-y install IP route. Did this? Yeah, 9.6. I was wondering if it was rel 10 based, because 10 just came out. I have conflicting opinions. I've been using Alma Linux, and I really like Alma Linux, but the problem is Alma Linux is based off of RHEL. And Red Hat has not been a very good open source steward. I'm kind of still salty about that. iPerf 3. All right, so iPerf. What about LDP? Oh, good. Ooh. So does that mean... Oh, good. I see host 2. Because what I need is I need to know the port. So AE90. So which one of these has AE90? Okay, it's this interface right here. I need to put an IP address on this. So IP adder. So IP address. No, IP. I can't remember the syntax. Configure IP address Linux. IP adder add. Add. So 10.1, 10, 12. Dev. And then it's AE9. E90. Did we learn that MAC address? One dB. Where'd that one come from? Yeah. Sudo docker exec /it host 1 bash. So do dnf-y install LLDP-D, and then turn on the LLDP daemon. That way on leaf 1. I can see that host 1, 71 Delta Bravo. Wherever that IP address is. Go back. Host 2. Oh, did I grab the wrong? Oh. That's annoying. How the heck am I supposed to? Both containers have the IP address on them, same IP address on them. Unless, oh, I just went to the wrong one. 71 Delta Bravo. Okay, I'm just. So Ethernet 1. That's interesting because that's host 1. Oh yeah, I was on the wrong host. So say sudo docker exec it host 2 bash. So it was Ethernet 2 in our case for AE90. Oh, that's right, man. That makes sense. Okay. So host 1 IPA address add 10.1, 10.11 device Ethernet 1. Okay, I can ping Ethernet 1. Cool, that's good. What about host 2? Ping 10.1, 10.1. Can't. So why can't I in host 2? IPA. I'm on leaf 4. Show LDP neighbor. AE90s on Ethernet 10. Show run. Ethernet 10. Oh, it's on VLAN 20, that's why. All right. Maybe that was a problem earlier. Yeah, it's easy to get mixed up in this. Oh, that's because it's connected to leaf 3. Okay, host 2, 43 alpha alpha. Four three alpha alpha. All right, that's on Ethernet 1. So IP adder, IP address, remove 10.1, 10.12 on dev Ethernet 2. Delete. Okay. So IP address, add 10.1, 10.12. Device Ethernet 1, ping 10.1, 10.1, 10.1. First verify IP address. So 43 alpha alpha on leaf 3. 43 alpha alpha is on Ethernet 10. Show run interface E10. Okay, interface E10. Switch port access VLAN 10. Try that again. Sometimes it takes a little bit to ARP. IPN is IP neighbor. It's like showing the ARP table. All right, finally. So now I can try the, I'm bridging across the fabric. I can try the multicast test now. iPerf 3 multicast. Do they do multi? Do they fix it? Do they not have multicast on iPerf 3? iPerf 3 doesn't have oh my gosh. How do you not have that? Hi, Wilson. Yeah, everything looks good now. So now we got to do DNF-Y install iPerf 2. No iPerf 2. Really? DNF install Elpo release. Apple. Not Elpo, Apple. Where do you get rel iPerf 2? I do not want to install this from source for Forge. Okay, good. Maybe it's just iPerf. Or DNF dash install Apple release. Then DNF dash Y install iPerf by itself. Now try this again. Can I ping 10.1, 10, 12? And I can. Okay, so I've got L2 connectivity. So I'm going to do 224.0.0.100. And I'll do... So pick that one because that's the range that always gets broadcast. It always goes to every host. There's no pruning on that one. Was it 0.0.100? Okay. We have multicast. Now, the question is, well, that... Show interface, counters, interface. There's not enough multicast packets. Oh. Why are they going across 1 and 2? What's going on in 1 and 2? How are there multicast packets going across these interfaces? These don't make any sense. Yeah, these counters don't make any sense. I'm sending all this traffic over. How's it getting there? Let's go to the spine. Looks like it's all going over the... Yeah, it might be. Oh, you know what? The default, because the default gate, if I do IP route, yeah, so I've got to IP route, delete, default, Ethernet 0. To route, add, default, dev, Ethernet 1. Yeah, it was going over. You're right. Same thing. All right, there we go. But it's coming out as unicast. Okay, so we do clear counters. Well, that's more multicast. Okay, it looks like it's working. No, it's not working. Ethernet 10 is the interface that the host is connected to, but Ethernet 3 is going to the spine, so that should be out unicast. It is not using multicast in the underlay. So, interface VXLAN 1, show run, interface VXLAN 1. Oh, mother. I forgot that it reconfigured everything. So, of course, it's not. Oh. This is one of the challenges you get when you're knee deep in changing all these different things. You lose track of what got changed, what didn't. When I redeployed the fabric, it defaulted back to the non-multicast underlay. So I've got to reconfigure the underlay. So at least I've got a good testing methodology. So that's good. So where's my... Under my templates, where's my spine leaf text. Okay, I'll go back to leaf 1 and copy, paste. I should copy and paste all this. And then I also have to do this on all leaves. Oh, config mode. Okay, got to go back in and do the sparse mode stuff because I wasn't in config mode. Okay, and then on the spines, set the rendezvous point. Just got to get the multicast infrastructure correct. Then leaf 1. Gotta configure this for the multicast group. Now, if I go to leaf 1, show IP PIM neighbor. Looks good. And I'll go to the spine, show IP PIM neighbor, make sure they all show up. And I'll show up, show IP mroute. Nothing yet. I shouldn't see anything yet. So on leaf 1, show run interface VXLAN 1 and interface VXLAN 1 and VXLAN VLAN 10 flood group 2390010. And if I do show IP mroute now, I should see, yeah, should see a join there because I do have rendezvous point, and the rendezvous point's an Anycast rendezvous point on the spines, but they don't have. I need to configure their IP addresses. The rendezvous points don't work just yet. Interface loopback 10. And on the router BGP, because it's PIM, it's piggybacks off of the off of whatever routing protocol you've got. I need to make sure that that's available. Okay. All right, that worked. And then I'll go to leaf 2 and interface config mode, interface VXLAN 1, and VXLAN VLAN 10 flood group 2390010. V3 conf base VXLAN 1, VXLAN VLAN 10 flood group 10. VXLAN 1, VXLAN VLAN 10 flood group 2390010. So if I do show IPM route, I should see a lot of joins. Okay, so I think that works. Let's try that test again. And now it's not working. Now let's see on leaf 3. I can get to the rendezvous point. If I do show interface counters, clear counters. So the packets are coming in, the multicast packets are coming in, but they're not getting encapsulated for multicast. So the flood frames, it's 224, so it should be flooded. Yeah, destroy to add the Alma Linux systems. And we're just not getting enough. So spine 1. Yeah, there's just not enough multicast traffic going over. So either I've got it configured wrong or it doesn't support it, which either one's a possibility. More likely I didn't configure it right, but. So what can I do to make it work? So let's try some other things. VXLAN, VLAN, interface, VXLAN 1, VXLAN, VLAN 10, multicast, group 2390010. Maybe perchance. Nope. Yeah, we're getting multipass packets in, but we're not. They check in, but they don't check out. VXLAN, VLAN 10, flood, group. Okay, VXLAN, VLAN 10, multicast, group. No. Commands. I did did I need to do query? IGB query? This is what AVD made. But I think this is, I don't think AVD supported doing multicast in the underlay. I think it just, this is how we do multicast in the overlay. I guess is right, but it's a bum frame. Is there a way to test a broadcast? Broadcast. Pinging the broadcast address. So we're getting in the broadcast packets, but it's not getting sent over. So it's not, we're not forwarding bum frames through multicast or any way really. So VLAN 10. What if I do no? Oops, no. Listening. So it says it sent it, but has not received it over on this side. Let's see if we can get this to work. Well, let's do this. Show run interface VXLAN 1. No. And then on leaf 1. Try to understand the behavior here. All right, it works when we're doing head-end replication. It won't work when we do multicast. Maybe my multicast is not set up right. That's always a possibility. Show IP PIM neighbor. Show IP PIM rendezvous point. Oh, there's no rendezvous point. That would cause a problemo. Thought I configured that. This is why cutting and pasting is a very bad idea. All right. So maybe we try this again. Interface VXLAN 1, VXLAN, VLAN 10, flood group 10, 239.00.10. Show IP PIM rendezvous point. I already had one there, so I was missing one on leaf 1, but I had it on. Maybe that was it. So no, that's not. That wasn't the problem. Well, maybe that was a problem, but it wasn't the solving the problem. Oh, interface VXLAN 1. Did I just do that? Oh. VXLAN, VLAN 10, VN, flood group 39.00.10. Still not receiving it. Still not getting encapsulated. I can ping that address. Should you be able to ping? I don't know. I don't know if we can ping a multicast address. So 2390010. Show run interface VXLAN 1. It's weird when I added that, it didn't attach to 23900. It didn't do a PIM join. For 11, just 10. So I don't know what triggers. Do I need to turn PIM on? IGP snooping? No, I don't need to. Because it's 224, it should be everywhere, so I shouldn't have to snoop. All right, I'm going to deploy the the AVD config. And see what happens there. All right. Yeah, I just need to fix this. Because it's not a port channel. Build the configs. Oh, it didn't like something. Oh, yeah. There we go. And deploy. So this was configured by AVD. All right, we can ping. Ping both sides. Okay, so we'll run the server again, and I'll run the client. All right, that did work. Let's see if that created... Why is it going out that? Oh, because I'm doing mlag. All right, let me configure this without mlag. Was it going out? Was that? Why were there so many packets going out? All right, no more mlag. So I can do that. Disabled. All right, traffic's going through. No M routes. So it's not doing anything. All right. I'm going to give up here. I'll think about it later. It's been 2 hours. So how in the heck was that even working? It must have been head-end replication. That must have been encapsulating VXLAN into a unicast, but it's not even showing up. Yeah, it's getting spread across Ethernet 3 and 4. But what are they? Yeah, 3 and 4 are the spines. Yeah, they're going unicast. They're being sent over unicast. Multicast packets come in, they get encapsulated into unicast packets, spread across. That is weird, and I don't know how not to do it. Okay. That's the management port. It could... It's not going over the management port, at least. We know that because we knew IPR. And that was an issue before. Yeah, so that's weird. I don't... At least we got a method to test it. Yeah. So it did configure a rendezvous point, but there's zero joins. All right, I'm gonna contact some people at Arista to see if they know what's going on. But that's it for today. I think that was more than enough. All right, thank you for watching, and